Welcome to Sitza.com. Here in this video we will discuss about the first law of thermodynamics and the expansion of the gas under the different conditions. If the gas expands under the isothermal condition, which means that the temperature remains the same, right? So therefore when the temperature doesn't change, the internal energy of the system, that will be zero. The change in internal energy will be zero. The delta U will be 0. From first law of thermodynamics, we know that the change in internal energy is equal to Q plus the work, right? And here, since the gas expands isothermal under the isothermal conditions, that means if the piston moves up and we are giving heat to the system, for example, and the piston moves up under the isothermal conditions, therefore this delta U here is 0. So Q will be equal to the work, so which is P delta V, right? So that means all the heat given to the system under the isothermal conditions will convert it into the work. So you can convert all the heat into the work if the system moves under the isothermal conditions. This is the maximum work that you can get. But again, we know that this is not practically, it's not possible, and this is one of the drawbacks of the first law of thermodynamics. Next is in case of adiabatic process. An adiabatic process is the one where the Q is 0. That means the system does not change any heat through the walls between the system and the surroundings. So therefore the Q here is 0. And again, from the first law of thermodynamics, if delta U is equal to Q plus P delta V, right? So that means Q here is 0. That means the change in internal energy will be equal to the work, P delta V. So that means if the piston moves up under the adiabatic conditions, the work done by the system will be equal to the decrease in the internal energy of the system, right? Because all the work is done at the expense of the internal energy of the system, right? So the internal energy change will be equal to the work done. And again, if you do the work on the system, if work is done on the system, that again will increase the internal energy of the system, because Q here is 0. This is an adiabatic process. There's no change of heat, there's no exchange of heat between the system and the surroundings through the walls, right? And what if you carry out a process at a constant volume, right? So that means we don't change the volume. Therefore, if we supply some heat to the system at a constant volume, that will increase the internal energy of the system, right? It will increase the internal energy of the system. So all the heat going to the system at constant volume will change the internal energy. It will increase the internal energy of the system. So if this is our gaseous system here, and you suppose here supply 100 kilojoules of heat, that will increase the internal energy of the system by the same amount, because from first law of thermodynamics, change in internal energy is equal to Q plus P delta V, which is the work. And if the system is under the constant volume, the delta V here, the work done is 0, because delta V is 0. So this term is 0. Therefore delta U will be equal to Q. Here we have a question. We have to calculate the Q, W, and the change in internal energy of the system of a 1 mole of a gas which absorbs 500 kilojoules of heat at constant volume, right? Constant volume, and temperature rises from 25 to 35 degrees Celsius. All right. So that means temperature is not constant. The temperature does change here, right? Therefore the internal energy will also change. But the system absorbs a heat of 500 kilojoules at constant volume, which means that when there is constant volume, the work, which actually is equal to P delta V, it will be 0. All right. Why it will be 0? Because the change in change in the volume is 0. the system absorbs the heat at a constant volume. So W is 0. From first law of thermodynamics, we know that internal energy change is equal to Q plus the W, and since here the work is 0, therefore all the heat given to the system, that will increase its internal energy. That is why you see the temperature change from 25 to 35 degrees Celsius. And now the question is, how much of the internal energy change will be there? That will be again the same, that will be equal to the heat supplied to the system. So Q here is 500 kilojoules, therefore the change in internal energy will be 500 joules here, right? This is the change in internal energy of the system, and Q is also the same. Alright, here we have one more question. We have to find the work done when an ideal gas expands from this volume 10 power minus 3 cubic meter to 10 power minus 2 cubic meters at this temperature against a constant pressure of 10 power 5 Newton square per square meter. So that means we have a gas, let's say this is our gaseous system, and the gas expands from its initial volume 10 power minus 3 cubic meters up to, let's say the final volume here is 10 power minus 2. So we have to find the work done during this expansion by the system. The work done is equal to minus P delta V, right? The system is moving up, so that's why I'm going to use the negative sign here, because this is the work done by the system. Alright, so the pressure here is 10 power 5 meters Newton square per square meter, and the volume, initial volume, the change in volume is the final volume and initial volume, which is 10 power minus 2. That means it is 0.01 minus the initial volume is 0.001. Alright, this is the change in volume, so it will be 10 power 5, and this is 0.009. This is the change in the volume, and it will be equal to minus 900 joules, or you can say it is minus 0.9 kilojoules of work, right? So this is the work done by the system when it expands from 10 power minus 3 cubic meters to 10 power minus 2 against a constant pressure of 10 power 5 Newton per square meter. Hope you got the concept. Thanks for watching the video. Bye for now.